right, we're going to be starting with tangents and circles today. It's in a big series on analytical geometry that Teacher Lee will be doing. Teacher Lee will be back on Thursday, and she will continue with you guys talking about circles. And today we're just going to be talking about tangents and circles. So I just want to find out, you can pop your answer in the chat. Who can tell us what is a tangent exactly? Does anybody know what is a tangent? Let's start there. Hi, Amahle.
Evening, ma'am.
Good evening. How's it going?
I'm writing yourself. A tangent is a line that touches this a circle at one point only.
Excellent, excellent, excellent,
Thank
excellent.
you.
So there's only one point where it's going to touch. No other place is going to touch. If it touches more than once, then we can't call it a tangent anymore. It's a chord. Okay, so yes, it touches the line at the circumference only once. So we know that when we are looking at this tangent touching this place only once, we can draw a line from the center of our circle to that point, to that tangent where it touches just once. And the angle that is created between our when we draw the line from our circle center to our tangent will be exactly 90 degrees. Now, this takes us back to quite a few things that we've seen before in mathematics. We know that if we have a 90-degree angle, we can possibly use Pythagoras, because what we're creating, if we go to our tangent and we create a point and we stop at a point, we've created a 90-degree triangle. That's a right-angled triangle, and we'll be able to solve for any of the length of the sides, including our radius, including the length of our tangent, and including the length of the line from the circle center to our point outside of the circle. Yes, Leanne, absolutely. You can call it an extended chord because it does go right through the circle itself, 100%. All right. So we also know from analytical geometry in grade 10 that if we've got a 90-degree angle between two lines that bisect, then we know that the gradient of both of those lines, the product of the gradients, will give us -1. Okay, this is all important information that we should already know at this point, but we're just going to make sure that we're recapping and we remember what it's all called. All right, now let's look at one more thing about tangents that we do know. We learned this not from analytical geometry, but from circle geometry first. Okay, so we're just kind of extending the circle geometry proof, or one of the theorems that we have for circle geometry. Does anybody remember? I've got a point B over here. Does anybody remember what this proof in circle geometry is called? It starts at B, and then I create a tangent on this side, and I create a tangent on that side of my circle. Anybody remember what it's called from circle geometry? Oh, it's not tan chord. I'll tell you that, it's not tan chord. Okay, remember, oh, and Lenovo, you need to tell us what your name is, so we're not calling you Lenovo. Okay, please let teacher Yolanda know who you are.
It's Fahin. We already know. It's okay, just in this class, Fahin. Fahin, sorry, we already know that Lenovo is Fahin.
Oh, all right. Hi, Fahin. All right. Okay. Okay, I will know. Thank you for that, teacher. For teacher Yules. All right. Nolazi says tangents to a point. Okay, cool. And I know. Thank you for trying. Lebogang says, is it converse tan chord theorem? No, it's not. No, it's not. Remember, in order for it to be tan chord, we would need a chord. And unfortunately, inside our circle at the moment, we don't have a chord. Okay, we have a line from the circle center. It doesn't cut through a major or a minor segment in my circle. Angelique says line at center to midpoint of chord, or line at center perpendicular to chord. No, because we don't have a chord, Angelique, we have a tangent. Okay, so a chord and a tangent. A chord would be something like this, guys. A chord would cut my circle twice. Okay, that's it, Malachi. That's the one I was looking for. Tangents from the same point, or as Linda says, tangents from a common point. Okay, so if you guys notice, okay, this point T over here is my, okay, the line TB over here, that is a tangent because it touches my circle once. And over here, line AB is also a tangent because it touches my circle once. Now, if both of these come from that same point B, if they're coming off of the same point B and they touch the same circle as tangents on either side, then a couple of things are known about this. We know that the length of TB is going to be the same as the length of AB. We know that there'll be a 90-degree angle over here, there'll be a 90-degree angle over there. And we also know that if we join line AT, something interesting is going to happen. Yes, somewhere we're going to be looking at tan chord, but I'm going to leave that to Teacher Lee because she's going to be doing that with you guys when you get to the next section that she'll be doing with you guys on Thursday. All right, so we're just going to be looking at this from an analytical standpoint, from an analytical geometry standpoint. Right, now I know that this is a line, okay? And if we were thinking analytical geometry, guys, what do we know about a line or a line segment? Anything that we know about a line segment from analytical geometry? Okay, what do we learn about a line? Yes, Zinke, hello.
Hello, ma'am. I don't know if I'm wrong, but that maybe they equal to 180.
No. Yes. Okay. Yes. So if there are two angles and they are adjacent, then we can say that they're equal to 180. Okay. Adjacent angles on a line. Yeah, sure. Adjacent angles on a line.
Well done,
Equal to 180. Okay, excellent. We know that angles on a straight line are equal. What can you tell me about the equation? What do we know about the equation of a line, guys? Yes, Amache, loving the energy.
The equation of a line is equal to y is equal to mx plus c, m being the gradient and c being the y-intercept.
Absolutely good. We know that we're going to have something's going to happen with a gradient somewhere because we've got a 90-degree angle. So there are gradients coming out of the wasu. All right. This is what we know about a line, that there's going to be a gradient. We're going to be able to calculate a gradient. We will have points. Okay, we will have points somewhere on our Cartesian plane. Our circle and our line will be on the Cartesian plane. We will have a gradient. We will have an intercept. If that is, if that's something that we're going to get, because our straight line will definitely intercept the y-axis somewhere. Can anybody tell me anything about the equation of a circle though? Because this will also be on our Cartesian plane. Okay, the equation of a circle. What do we do? Anybody remember the equation of a circle? It's quite a nice one. It's one of my favorites.
Please, guys, raise your hand. There we go, Lisa. Well done.
Hello, Lisa.
Okay. I think it's x squared plus y squared is equal to r squared.
Beautiful. That's exactly what I was looking for, my sweetie. Can we extend it a little bit? The x squared plus y squared is more of a grade 11 concept. Okay, and this would be our circle at the origin, right, with center at the origin. This is a circle with center at 0, 0. Okay, what do we know about the equation of a circle when our center is not at the origin of our Cartesian plane? Okay. Lisa, do you know the answer to this one as well? All right, let me see if Leanne can answer this one first. Hi, Leanne.
Hi, ma'am.
Hello, my sweetie.
I think the equation is x into x. Sorry.
No worries, my sweetie. Okay. All right.
I was saying it's into x minus a all squared plus y minus b all squared equals to r squared.
Excellent. Is equal to r.
Well done, Leanne.
Oh, wonderful stuff, Leanne. Very well. Your name is Leanne, yes? I hope I'm reading that correctly and I'm not making things up.
Yes,
Okay,
it's
excellent.
perfect.
All right. Thank you, my sweetie. All right, good stuff. All right. So we're all on the same page in terms of all of these. Now, remember, guys, I'm going to have a circle. I'm going to have a circle. And then I'm going to have a tangent. And I know that wherever two things touch, much like when we're doing functions, if I have, let's say, a parabola and I have a straight line, I know that something happens at these points of contact. And we're going to have this same kind of situation on when we get to circles and tangents, because they touch the circle. Okay. We know that somewhere, somehow, the equation of a circle and the equation of a line are going to meet. Okay, they're going to tell us something very important. All right, let's have a look at one example, and we're going to try and go through this together and make sure we're understanding what's happened. All right, so example 8 over here says, determine the equation of the tangent to the circle x minus 3 squared plus y minus 1 squared is equal to 25. Now, this equation that they've given us over here is very, very important. Okay, this is a very, very important equation. Okay, because it tells us many, many things. All right, I'm just going to repeat what Lisa said. Okay, Lisa said to us that x squared plus y squared is equal to r squared. And if we look at our equation of a circle, we know that our r squared, in this case, r squared is going to equal to 25. It's 25. That's what they've given us. What does that then tell me about my radius, guys? What would my radius be equal to? That's it, Farine. Hello, my sweetie. Good. My radius is going to equal 5. Right? Good. So this is some very helpful information over here. They've given us that radius part that gives us 25. Okay. What does the rest of this tell me? What does the x minus 3 tell me? And what does the y minus 1 tell me? What do we know about that minus 3 and that minus 1 that's added there in the middle? Who remembers? Good, the coordinates of my center. Good, it's the coordinates, the x and y coordinates of my circle center. So my circle C over here sits at 3 and 1. Right, good. It's those coordinates. Now I know if I draw this line this way, like that, okay, what am I going to have over here? I'm going to have a right angled triangle, because we said that if a tangent touches the circle, then the line from the center to the point of tangency is going to give us a 90-degree angle. Now, I want us to note something very important, and I hope you guys will write this down as we go. Okay, whenever they ask for the equation of the tangent, we always need to think of the tangent as a line. Okay, the tangent is always a line. It's never just going to be a point that we're looking at. The tangent is always going to be considered a line. Now, because they've already given us the equation of our circle, what do you guys think we need to be looking for in terms of the equation of our tangent? What formula would we possibly use? Good, that's it, Nhlanhla. Well done, 100%. We're going to have to be looking at the gradient, right? But I'm gonna bump into a little bit of a problem, because if I calculate my gradient M, I've got 2 points. I've got the point 3 and 1, and I've got the point 6 and 5. This gradient is going to give me, or these 2 points are going to give me the gradient of line CS. They're going to give me the gradient of this part, of that part. But I don't want the gradient of that part, because I'm trying to find the equation of my tangent, right? So what are we going to do with these gradients once we have them? What do we remember? I can quickly refresh your memory. Let me go up a little bit and see if anybody sees it. Okay, we would multiply. Yes, we would. Good. Okay, if we multiply, what are we multiplying it with? Okay. Somebody named Favor and Family is giving me the equation of a straight line, but not quite. All right, Nkandla's onto something there. All right, we're going to multiply to get -1. Okay, because we know that the gradient of our tangent multiplied by the gradient of our radius is equal to -1. So if we have the gradient, which is what we're about to calculate, the gradient of the radius, we can multiply it with the gradient of the tangent, and together they must equal -1. Okay, gradient of the tangent times the gradient of the radius is equal to -1. And we can figure that out, right? That's quite easy. We can figure out the gradient of CS. Who can give us the gradient of CS? I see Lisa's already done it. Like wasted no time. Wasted no time at all. All right, good. All right, Lisa's got that one and she's already given us the gradient of the tangent. Now, if we calculate the gradient of the radius, I'm just going to go 5 minus 1 over 6 minus 3, and that is indeed equal to 4 over 3. Now, that is the gradient of our radius. So I'm going to go the gradient of our radius times the gradient of my tangent is equal to -1. I'm going to substitute the correct things where they need to go. I know that the gradient of my radius over here is 4 over 3 times something, which is the gradient of my tangent, is equal to -1. Now we need to find out what that something is. Okay. Now, if we remember anything from grade 10 analytical geometry, we know what we can do here is we can just flip these two around. So make that 3 over 4. And if it's positive, we just make this one negative. If that one's negative, we just make the other one positive. All right, so the gradient of my tangent will be equal to -3 over 4. M of the tangent is equal to -3 over 4. But I'm not done because my question is asking me for the equation of the tangent, right? Now we have to look at using y is equal to mx plus c. Yes, absolutely. So Leanne says we can divide both sides by 4 over 3. We can absolutely do that as well, and that will give us the answer we're looking for. I just feel like when we just do the reciprocal and then put a minus sign, it makes it just a little bit easier. But if you would like to, you can do that. You can divide by 4 over 3. Oh, I'm lying. Yeah, divide by 4 over 3, and then over here also divide by 4 over 3, and then that would just invert and give us what we're looking for. Okay, now we've got our gradient. We know that our gradient is -3 over 4, so we can replace that. Y is equal to -3 over 4 x plus c. Okay, we need to find c, guys. We need to find the intercept. Now, I need us to be very careful. In this particular question, we cannot by any means, when looking at the equation of our tangent, use the center. We cannot use the point at the center. We do not do that because the point at the center is not part of our tangent. We need to make sure that we're using the point that is at the actual tangent. Okay, make sure that you're using that point. So we're going to sub in the 0.65. Okay. So I'm going to get 5 is equal to 3 over 4 x. Oh, my x is actually equal to 6. 3 over 4 times 6 plus c. And if we solve for c over here, I'm going to get 9 over 4. 5 is equal to 18 over 4 plus c. 5 minus 18 over 4 is equal to c. 20. How do I get from that to 4? 20 minus 4, that should give us a half. Okay. Correct. I should get positive a half. I'm seeing somebody giving me negative a half. Yes, it is. Oh, so sorry, Linda. Yes, this is negative. Negative. So when it comes this side, it'll be positive. Thank you very much. Thank you. Sorry, Linda. Yeah, I forgot the negative, guys. So when it comes over, it will be positive. This will become 38/4. Okay. If we make it simpler, it will give us 9. This is equal to C. 19/2 is equal to C. So my equation of my tangent will be y. I'm just going to write it up here. Y is equal to -3/4 x plus 19/2. Okay. All right. Can I just see, can I get a thumbs up from everyone in the chat? Are we okay with calculating the gradient of, or calculating the equation of the tangent to a circle? All right, excellent, guys. I'm seeing it. If you're not feeling 100% about it, go ahead and say, ma'am, you lost me somewhere. Please explain again what's going on over here. I'm not 100% sure. Please raise your hand if you can to ask a question, just so you're feeling very comfortable with the section, okay? Okay. All right. Jeanette says, please explain again. All right. Jeanette, I need you to tell me exactly where it is that I lost you in this particular question. Linda says, ma'am, could you have C as a decimal? Yes, you could. You could, Linda, but we don't actually recommend it as much, okay? Because some fractions have many decimals and then it starts looking messy, and we don't want that, okay? So they will expect your answer, they will take your answer as a fraction as it is, okay? All right, Leanne, just be sure that your 19/2 is positive and not negative. Okay. Yeah, Bonolo, the problem is always the rounding off. That's why we don't want you using decimals. Okay. The problem is the rounding off. In case the next question needs you to use that answer and it doesn't need the rounded off answer. Okay, so we try our best not to round off where possible. Okay, Jeanette, can I just ask you to put a pointed question? Oh, okay. All right. Jeanette says from substituting 6/5. Okay, 6 and 5. Okay, so this is the part over here. And it's basic math. It's literally basic math that we're doing here. We know that we've got our gradient of our tangent, and this is our tangent over here. We've got that gradient over here. Now, the only line or the only point that lies on the tangent line is this one, 6 and 5, right? So that's why we're subbing in 6 and 5. We can't sub in 3 and 1. It's not on our line. It's not on our tangent. Okay, so we have to sub in the point 6 and 5. So we can go, our y value is 5. 5 is equal to -3/4 multiplied by our x value, which is 6, plus c. Okay, and then you can just do some basic math. And if it's still a little bit difficult, just punch it into your calculator very quickly. 5 is equal to -3/4 times 6 will give me -18/4 plus c. And now because I want to isolate c, I'm going to take -18/4 to the other side. Okay, and that will give me 5 plus 18/4 is equal to c. Grab a calculator, pick up a calculator and put this into the calculator. And it will give you the answer, 19/2. Therefore, c is equal to 19/2. Okay, Zinka says, can you please scroll up, ma'am? I want to take a screenshot of the first example. This is the first example we've done, my sweetie. Okay, unless you're talking about the explanation at the top. Yes, Linda, that is correct. Yes. Okay, here it is. Let me just highlight it so that we know where it is. There we go, right over there. Y is equal to -3/4x plus 19/2. Okay, excellent. The one with the kite. Okay. Okay, I'm going to give you 10 seconds while I take Chiwafato's question. Okay, there we go. Yes, Chiwafato.
Hi, ma'am. How are you?
I'm good, thank you. How are you, my sweetie?
I'm good, ma'am. So, ma'am, we're using the point 6 and 5 to sum into the equation, not the other one, 3 of 1.
Yes, because 3 of 1 is not part of our tangent. 3 of 1 is the circle center, and the circle center is not on our straight line.
So we use the points that are on the straight line.
Yes, absolutely, because that point is part of the straight line. This one is not part. This one is not part of our straight line, so we can't use it.
Oh, okay. Thank you, ma'am.
Okay, you're very welcome, my sweetie. All right, let's have a look at another example. I'm going to give you guys some time to do this one on your own. Okay. Yes, so Kuma's asking, is this analytical and geometry all together? Yes, it is. Okay, Witepo, can I go back in just a little bit? I would like everybody to try this example that we've got over here. Okay. Have a look at what you've been given, guys. And remember, they're asking you for they're saying, fine. So we're looking for the straight line that the equation of the straight line that touches our circle. Okay, I'm just going to give you guys a couple minutes. Let's do this. This is my favorite emoji ever. Once you're done with the question, pop the fire emoji in the chat for me. Okay.
Did your Coco freeze?
Yes.
Oh, you still there? Okay, still there. Let's try, guys. Let's try this question.
I'm sure it looked like I was frozen, but I'm actually
you are very focusing. Then I'm
I'm using the brain cells to like do the math.
Yeah.
The math within the brain. You know what I mean?
So for a second, I was like, what happened? Let's try it, guys. We can do it. We can do this.
I'm still here. Lisa is done. Which is awesome. Let's just give everybody else Spongile is done as well. Thank you, Spongile. Thank you, Lilita. Spongentle. Okay. I'm going to get that right. I'm so sorry, Spongentle. All right. Yes, I didn't read the last part. I just assumed. I'm very sorry, my sweetie. I'll get that correct. I will make sure. All right, there we go. Thank you, Malachi. And Nkateko's also done, and Tiamo and Bunolo. And Danelle, Leanne, Gadi. Gadi and I share a surname. I love that. Love, love, love it. See, great minds, great Mama Polo minds do maths. So I love it. Well done. All right, guys. Okay, let's go through this quickly and let's see how everybody's managed to do. All right, so they've given us a bit of a complicated equation of this circle here, which, you know, most times we wouldn't actually have that, we wouldn't have it that easy, in that they wouldn't then give us the diagram. But we can already tell that they've given us the point that we're looking for. Can I just ask quickly before we continue, if they hadn't given us this point, let's say for instance they hadn't given us this point, how would we have used this information that they've given us up here to figure out what my circle center coordinates would have been? Yes, Teddy.
Ma'am, we would have the coefficient of x half times the coefficient of x, the same with y, and then we add those values to the right hand side, and then we will eventually do the steps, get there.
100%. We would then, we call it completing the square, but we're doing simultaneous completing the square. Yes?
Yes.
Good. We're doing it for X and for Y at the same time. I can see you guys have been studying. Yeah, it's showing, guys, it's showing. Okay, so this was a lot easier because Teacher Lee was kind enough to give us the points that we needed, right? So we can go ahead and look for the gradient of this line over here. So if you look for the gradient over there, I'm just going to name this O and M, otherwise it's not going to be so lekker. Okay, the gradient of OM would have been 2 minus -1 over 4 minus 3, and that would have given me 3 over 1, which is just 3 really. All right, so my gradient of OM is 3, but I don't want the gradient of OM, I want the gradient of the tangent. So if the gradient 3 times something is equal to -1, we know that we're just going to divide both sides by 3, or we're just going to take the reciprocal of 3, which is 1 over 3. 1 over 3, and make it negative. So the gradient of our tangent is equal to -1 over 3. Okay, yes, Farine, well done. Excellent. Okay, now we've got to look at the equation of our straight line, which is the tangent. So we're going to go y is equal to mx plus c. Our y, or our m, is going to equal to -1 over 3x plus c. And then we need to sub in the point that is on our tangent, not the one at the circle center. So we need to sub in the point 4, 2. Okay, so we're going to get 2 is equal to -1 over 3 multiplied by 4 plus c, and then we can solve for c here. All right, I'm going to get 2 is equal to, let me write it a little bit closer. 2 is equal to -4 over 3 plus c, and then we're going to take the -4 over to the other side. So we're going to get, I'm just going to finish over here. C is equal to 2 plus 4 over 3, which is the same as 10 over 3. Therefore, the equation of our tangent, y is equal to -1 over 3x plus 10 over 3. Give me a thumbs up if you managed to get that correct. Oh, Lisa's looking so chuffed with herself. Excellent, excellent. Okay, Leanne, I'm going to explain quickly. I'm going to explain to you, my sweetie. All right, excellent. Yes, is it Kiabetswe? I hope I'm saying that correctly. Hi, Kiabetswe. Oh, her hand is up. I think she may have meant thumbs up. All right. Okay. Leanne is asking me, why did we divide by, let me just make sure I'm getting the correct question. Why did we divide it by -1/3? Okay, my sweetie, we didn't actually divide by -1/3. We multiplied by -1/3. So you agree with me that this m over here is missing, right? The m over there is missing. And if I want to get rid of this 3 times, I would then divide this side by 3 and divide that side by 3. So this will then become m is equal to -1/3. But what I've actually done is I've just multiplied by the reciprocal. What I've actually done is multiplied by the reciprocal. So if this is 3, and I want my answer to multiply to give me -1, I need to multiply by -1/3 to get that. Because I know that I can rewrite 3 as 3/1. I'm just going to take the 3 and the 1, flip them over, and change the sign from a positive to a negative. Yes, Jeanette, always a fraction. Okay. We want to make sure that we're always getting a fraction. Okay. You're very welcome, my sweetie. Yes. Okay. Okay, Linda's saying, ma'am, how many marks does this weigh? In this case, because the question was quite easy, they've given us all the information we were looking for. You would get 1 mark for the tangent, okay, 1 mark for the finding C, and possibly 1 mark for your final equation. So 3 marks on the matric level. Okay, it may be a couple more marks, maybe 1 extra mark at the grade 11 level, but about 3 marks, because it is just routine procedure. We're not doing anything we've never seen before. It's just going to be that easy as it was. Witepo says, ma'am, would it be a problem if I wrote the fraction as a mixed fraction? Not at all. You can absolutely do that. Okay, there's no issues around that at all. Okay, all right, let's have a look at another example. Let me see. Okay, Teacher Lee put quite a lot of space in between these two. All right, so we're going to be doing things a little bit differently now. Let's look at the information we've been given here. It says here, in the diagram alongside, M, which is -2 and 1, is the center of the circle. So they've given us the center of the circle. Now they've given us the line, y is equal to 1/2 x plus 7. They're saying that this line is a tangent to the circle at P. So we know that the line touches at the point P, right? Calculate the coordinates of P, right? Okay, now, does anybody, if you do have an idea of what we're going to do, can I ask you to put that in the chat, or you can even raise your hand and let us know what you think we're going to do here. Okay, Fahina is saying we're going to insert 1 by y. Okay. That wouldn't work, Fahin, because remember, the only way I can possibly put a 1 here is if the actual coordinate of y was on my tangent, but the coordinate of y is not on my tangent. Okay. Linda says, can we use the formula for y minus y1? No, we can't. What we're actually looking for is the point on the actual line. Anybody else? Anybody got any idea? All right, let me ask you guys, let me take you back to grade 11 functions. Okay, oh, Teddy, yes.
What I'm thinking now, ma'am, I'm looking at the gradient, you know. We have a half, and we know the tan red theorem states that
yes.
We need to have a -1, eh? So I see a half times -2 give us a -1.
Aha, okay.
Does ma'am see where I'm going though?
I absolutely get where you're going, and you've actually just burst the bubble, 100%. I was just about to explain. Okay, very well done. Teddy has just hit the nail on the head. All right, if I had to draw a line from here, and Lisa, you're not wrong. You're not wrong at all. it will just take us a lot longer to get there. Sharon, that negative b over 2a, we can only use that for hyperbolas and parabolas. Okay, now if I draw a line from P to M, I know that this is actually a 90-degree angle, right? So now this time they've given me the gradient of my tangent. What else can I find, guys? If I've got the gradient of my tangent, what else can I find? Which other gradient am I able to find? That's it. Yes, Zinke. We can find the gradient of my radius. Right. So I know I've got the gradient of my tangent multiplied by the gradient of my radius will give us -1. Okay. We've just looked at this. So instead of finding the equation, or instead of going the long way around and finding the equation of the circle, we can find the equation to that line, right? And then that will help us to equate the two y's as we're going. All right, so I want you guys to pop in the chat for me. What is the gradient of my radius? What is my m rad? What is my m rad? Okay, I know that this is a half times m rad is equal to -2, or is equal to -1. So we can divide by a half, and the answer that we'll get over here is -2. Good. So we know that the gradient of the radius is equal to -2, right? What can we do with this information now that it's been given to us? That's it, Sibahle, very well done. Okay, they've given us this. And remember, guys, from M to P, that's also a straight line. So what can I find in terms of the gradient of my radius over here? What can I look for? Not quite the y-intercept, but think about what we've been given in Kanka. They've given us this line. Aha, there we go. Yes, Amahle.
No, someone already said the answer, but I was going to say that we have to use the coordinates of m in the equation of y is equal to mx plus c. Excellent,
100%. You and Sisipo are on the money. We need to find the equation of the straight line MP. Okay, so we can then go y is equal to -2x plus c, and we can now use this point because this point M lies on my straight line MP, and I can sub in the point -2 and 1. All right. Let's see if you guys can find C. Pop your answers for C in the chat. I'm going to go at it slowly while we do this together. All right, -2 times -2 plus C. Okay, y is equal to 4 plus C. All right. Ooh, not 5, Leanne. 1 minus 4 is equal to C. Therefore, C is equal to, well done, Google it too. That's it, Sipo and Fahim, good. I think you just forgot that 4, when it goes over, it becomes negative. Therefore, C is equal to -3. All right, so this is what I've got, guys. This is the information they've given me so far. I've got y is equal to a half x, and I don't want to get this wrong, a half x plus 7. And now, with this new equation we've just calculated, I've got y is equal to -2x minus 3. And I've got y is equal to -2x minus 3. What can we do with this information that we've just now acquired for ourselves? Aha, that's it, Malibongwe. Lebogang says, ma'am, where did the +7 come from? It comes from this equation over here, my sweetie, this one, the equation of the line that they've given us. Okay, good. Malibongwe's got the right idea. Because this is equal to y, and this is also equal to y, we can equate them because they're both equal to y. So we can then say a half x plus 7 is equal to -2x minus 3. And then we can solve for x. I would like you guys to do that for me quickly. Okay, shift things around. You know how we do with the maths. Shift things from one side to the other. Blah, blah, blah. Let's find the value of x. We get a half x plus 2x is equal to negative 10. Right. And then I would get 5 over 2x is equal to negative 10. Yeah. Nkanta says x is equal to 4. You're missing a negative there. Leanne says, would it be wrong to solve simultaneously? No, because that's actually what I've done. It's exactly what we've done, Leanne. You can even name this one 1 and name this one 2. So we're basically substituting. It's simultaneous equation by substitution. Okay, it's exactly the same thing that we've done here. Okay, I'm going to multiply both sides by 2, so I'll get 5x is equal to negative 20, and then x is equal to negative 4. Okay, Lebogang, I saw that hand go up and straight down. I don't want you to stay with any question marks. So if you're still feeling a little apprehensive, you can still put that hand up, and I'm happy to answer your question. Okay, am I done? Are we done? We've got the answer for x. Am I finished? No, I'm not done, because the equation actually asked me for the coordinates of P. At the moment, I have the x coordinate. I still, yes, Svongenke, that's it. I still need to go and find the y coordinate. So I can use any of the 2 equations that I got. I personally think fractions suck, so I'm not going to use the one with fractions in it. I don't like them, never did, never. I'd rather work with a negative than a fraction. But whatever floats your boat, guys, if you feel like you want to use the fraction, go for it. Me, on the other hand, I'm using the other one. I don't like fractions. Y is equal to negative 2 times negative 4 minus 3, which is equal to 8 minus 3, which is indeed 5. All right, so my coordinates for P are negative 4 and 5. All right. Okay. Give me a thumbs up if we're feeling okay about these. How do we feel about this? I just want to make sure that you guys are still okay and you're looking at the steps that we're taking in order to get to the answers that we're getting to. Excellent, guys. Well done, Malibongwe. Angelique is having so much fun, love it. Stogazil is asking, how did I get negative 10? So if I take the negative 2x over to that side, my sweetie, it becomes positive 2x. And if I take the positive 7 over to that side, it's going to become negative 7. So I ended up with negative 3 minus 7, and that gave me negative 10. Okay. I just skipped a step, and I'm realizing maybe I shouldn't. Okay, sure. All right, okay. I'm glad we're all on the same page. Okay, all right. Let's have a look at one more very quickly because we do have to go. Okay, we've got about 4 minutes, 5 minutes, 5 minutes. All right, now it says again, the line y plus 2x is equal to 11 is a tangent to the circle center, to a circle center P at 1 is equal to, at 1 and negative 1 at the point Q. And then they ask you to first find the radius of PQ. How are we going to find the radius, guys? Let's think about this. What formula do we know when we look at, circles and tangents? What formula are we going to use here? Anybody can raise their hand and let us know. Straight line, Teddy, we're looking for a radius. We're looking for a radius. Yes, Zinke.
M tan times M radius.
not quite, guys. Remember, we're looking for the, we're looking for the equation of the radius. Okay, the equation of the radius. Okay, not the actual length of the radius. Okay, so yes, you're correct. Yes, the equation of the straight line. Teddy, 100%. I'm so sorry about that. Thank you, Zintle. Sorry, I thought they wanted just the radius. So it's looking a little, okay, good. So we're going to use m tan times m rad is equal to -1. Now there's an issue here before we even go there. What's going on over here? What's going on? Jeanette, do you see what the issue over there is? Jeanette isn't unmuting. Hi, my sweetie. Oh, there we go. Hi.
No, I don't.
Okay. All right. If we had to look at this equation of the line, what is my what is my tangent?
Sorry?
Look at this equation of the line that they've given us over here. What is my tangent going to be?
2.
Oh, no. Is it?
Is it going to be y equals to -2x plus 11?
That's it. First, we need to rearrange it. We need to put it in standard form. So we first have to do y is equal to -2x plus 11. Now, what is the gradient of my tangent? What is the gradient of my tangent? Do we see it, Jeanette?
Yeah, I think it's -2.
It's -2, my sweetie. All right. Do you know what to do from then on?
Yes, I think I know.
Good. All right. Good. I've given you the clue that we're looking for.
Yeah,
The gradient of this line is -2, so we need to find the gradient.
Yes, yeah.
Okay, excellent. Take it from there, my sweetie. All right, I'm going to give everybody the rest of the time to go ahead and do the question. Okay, find me the equation of radius PQ, and you can drop your answer in the chat once you're done. And then it says, determine the equation of the circle through Q with center P. All right, okay, good. So everybody's figured out that the m rad, or the gradient of my radius, is 1/2. But your job is not done, guys. Your job is not done. You still need to find me the equation of the line, or the equation of the radius. Okay. Nkaka, I'm not sure where we got that -1.5, but have a look again, my sweetie. All right, Violet's got an answer for us. Excellent, ma'am. Malachi says, ma'am, how did you get 1/2? All right, we know that the gradient of our tangent, Malachi, is 2. Okay, so now I've got 2 times something needs to give us -1. Remember, we talked about flipping it over. Okay, so we're going to take 2 over 1, and we're going to flip it around, and it's going to give us 1 over 2, and we're going to change the sign, negative. Or you can just divide both sides by 2. Okay. All right. Okay, let's get to this equation because we have actually run out of time for today. All right, so I'm going to write y is equal to 1 over 2 x plus c. Sure. All right, if I want to find c, I'm going to sub in the point here. the one in the middle, not the one of the tangent. I don't even have a point on my tangent. So I'm going to sub in that point. So I'm going to go -1 is equal to 1/2 times 1 plus c. And then this will go over to that side. I'll get -1 minus 1/2 is equal to c. Therefore, c is equal to -3/2. The equation you should have gotten is y is equal to 1/2 x minus 3/2. All right, give me your funkiest, most loveliest emoji in the chat if you managed to get that question correct.